Hi everyone, and welcome to today's webinar, where we'll dive into different strategies used to protect JavaScript source code, including obfuscation and other techniques. So as you might expect, this webinar will be quite technical. Don't worry though, because you will get the recording automatically at the end of the webinar, so you can go through any specific part of the webinar again. I want to start by letting you know that this webinar has been pre-recorded, so if you have any questions, you can reach out to us at hello@jscrambler.com and we will gladly answer them. And speak of the devil, let me begin by welcoming our host for today. I'm thrilled to be receiving Luís Reis from the Jscrambler development team. Luís has a PhD in computer science, where he specialized in compilers for parallel programming. He's one of the masterminds, dare I say, behind Jscrambler's JavaScript protection product, Code Integrity. And so he knows pretty much everything there is to know about JavaScript obfuscation and runtime protection. Luís, thank you so much for joining us today. And feel free to get us going.
Thank you, Philip, and hi to everyone joining today. Well, it's always great to have the chance to explore this topic of JavaScript protection and obfuscation. And, like Philip mentioned, this webinar will be a bit technical, because I will be getting into some detail. Okay, let me start by framing the topic before we get started on JavaScript obfuscation. This could go without saying, but JavaScript is pretty much everywhere these days, and this development ecosystem started growing a lot since the release of Node.js, as well as frameworks and libs like jQuery, React, and Angular. Today, we have lots of cross-platform runtimes and frameworks like React Native, Ionic, NativeScript, and Electron. So this means that JavaScript is not only used in web apps, but also mobile and desktop apps. And because more and more developers use these frameworks, now even your mobile banking apps or streaming services are built with JavaScript. But if these critical apps are running JavaScript, we need to understand the changes to our threat models that come from using JavaScript. Client-side JavaScript is always exposed. This means that anyone can debug our code and go through it. And this happens because this JavaScript needs to be sent to the browser, otherwise the browser isn't able to execute it. Still, this wouldn't be a problem if we were talking about simple web applications or websites. But in reality, companies are frequently storing important business logic on the client side of their apps. If you understand the basics of application security, you know that code secrets should always be kept on trusted execution environments like the backend server. But this is one of those cases where practice takes precedence over theory. This may happen because there's not a backend in the first place, as is in the case of some mobile app applications. Then, you may have some code that might be related to the user experience, like an analytics algorithm that must be run on the client side. Still, the most common reason to ship code to the client side is performance. Server calls can take time, and when you have a service where performance is crucial, like a streaming platform or an HTML5 game, storing all the JavaScript on the server is not an option. Whatever the case, companies usually don't want to expose their proprietary logic, and they definitely never want to expose code secrets, especially when their competitors can reverse engineer the code and copy proprietary algorithms. And then we have more advanced attacks like using bots to automate the creation of new accounts, or trying to remove digital watermarks in premium video content, or even unlocking advantages in a game without paying. And there's also the problem of data exfiltration, because when the attacker has access to the source code, this can facilitate planning and automating complex attacks that try to trick users or steal their data. So, how can we prevent this? Well, you may have thought about encryption, but encrypting JavaScript doesn't really work, because if we have a decryption key we need to supply to the browser, that key can be compromised and this code easily accessed. And this could go without saying, but SAST and DAST tools don't deal with this security weakness. Of course, SAST and DAST should be used to find and fix vulnerabilities in our JavaScript code. But our code will still be in plain sight, so we should use SAST and DAST alongside JavaScript source code protection. So, what can we actually do to protect the source code? Well, if we look at security standards like ISO 27001, we see that their recommendations include restricting access to the source code. Also, we can turn to widely accepted guides for application security, like the ones from OWASP, the Open Web Application Security Project. And their guide of the top 10 mobile app threats is very clear in this regard. To prevent reverse engineering, you must use obfuscation. So, this brings us to our main topic for the day, JavaScript obfuscation. JavaScript obfuscation is used to transform our source code into something that is extremely hard to understand and reverse engineer, but that preserves its original functionality, like you can see in this image here. So to a browser, this mangled code is exactly the same as our original code and will run without any problems. Obfuscation is often confused with minification, but minifiers only reduce the code size by removing useless characters like white spaces. They don't protect the source code in any way. Some of you may have also used code optimizers and code compressors, but while they can incidentally also make the code harder to read, they offer no actual protection, since their primary purpose is to help with performance and code size. And I'll explain what I mean by actual protection later on, when I introduce the metrics used to measure obfuscation. For now, let's take a moment to look at a real example of JavaScript obfuscation. Let's consider this code snippet here, which is an algorithm that is used to recommend products to the shoppers in an e-commerce website. As you can see, this code generates a list of product recommendations for a given customer based on that customer's history of previous purchases. This seems like pretty ordinary code, but let's imagine that this is a proprietary algorithm developed by this company. If I was a competitor visiting this website, I could quickly find this code and do with it as I wanted. Even if the store admins had minified this code, it will do nothing to hide their algorithm, as you can still see every function, variable, and string. Now let's see what happens when we add a single JavaScript obfuscation transformation. Here, I have used the control flow flattening transformation by Jscrambler. The whole program flow was flattened, and every single natural conditional construct that makes the code easier to read is now gone. And I don't know if you can see this comment here at the end, but this is just a snippet of the protected code. The full version was almost 700 lines of code. Still, a single protection wouldn't be enough if I wanted to make sure that my code was protected. This specific transformation doesn't change any of the names, numbers, and strings, and if I scroll or search for some of these names, I will find them somewhere along the code. This is why JavaScript obfuscation suitable for enterprise or commercial apps must include not just one, but multiple transformations. And here on the right, you can see just how many transformations can be used to obfuscate the source code as best as possible. Many of these transformations actually enhance one another, but today I don't really have the time to explore this in detail. In any case, here's what the end result would look like. And again, this is just a snippet of the code protected with a combination of 11 JavaScript transformations. So now we can't find any of the original functions and objects. Someone may try to go through the code, but they will get only this garbage looking code that doesn't really take them anywhere. But this code will still work just like the original. So now we have a better idea of what JavaScript obfuscation is. You get unintelligible code that runs like the original, but makes life extremely difficult for anyone wanting to reverse engineer it. Still, there are some questions we need to ask. Is this enough protection? when attackers try to reverse engineer to use reverse engineering tools, and want the protected code run very slowly since it's so large. These are three questions that have been studied by researchers. This paper here, you see here, is one of the most relevant studies on code obfuscation and highlights three metrics to measure obfuscation: potency, resilience, and cost. And these metrics are very important because they provide the best way to measure if your code is well protected or if certain obfuscation tool is actually weak. So let's start with potency. Potency measures how difficult it is for a human to understand the obfuscated code when compared to the original code. This can be calculated using complex formulas, and the resulting metrics will allow us to determine the impact of the transformations in the code. But there are some rules that as to what makes a high potency transformation, like hiding constants and names and making it really difficult to understand the order in which the code is executed. But I won't go much further into the theory behind it. Let's instead look at an example of a very potent transformation. So this is code that has a non-alphanumeric obfuscation, which you don't often find in the wild. The potency of this obfuscation is definitely high, since it seems impossible for a human to understand the obfuscated code. But that alone doesn't make it a good transformation. Let's see what happens when we run this code through a deobfuscator. So yeah, it quickly returns the original code, which is simply alert 1. So we were able to defeat this obfuscation in a single step. A key takeaway here is that just because a piece of obfuscated code seems extremely hard to understand, it doesn't mean that the obfuscation is good unless you can somehow survive these reverse engineering tools. And that's where resilience comes in. Resilience measures how well a transformation holds up when under attack from an automatic deobfuscator. For example, we can add an if statement that introduces a dummy variable. It may take a while for a human to identify the code as dummy code, but a deobfuscator will immediately remove the statement. This is why resilience is calculated by considering the amount of time required to develop a deobfuscator capable of reverting a transformation's result and require execution time and space by a deobfuscator to effectively revert the transformation. This is a metric where most obfuscation tools fail. When comparing different obfuscation results, we can simply trust our eyes and perception. Finally, we have the cost metric, which represents the impact of a transformation in the execution time of a transformed application, as well as the impact on the application's file size. This is important because you wouldn't want your application performance to be ruined due to obfuscation, especially when you have a client-facing app and could be losing money if this app starts running very slowly. A good obfuscation tool should always provide specific features to minimize the performance hits and also allow you to fine-tune the transformations throughout your code. Understanding these three metrics is probably the most important thing you can do to properly choose a good obfuscation technology. But when you're protecting your app from advanced attacks like piracy, abuse, and data exfiltration, obfuscation is really only one of several layers of protection you can use. One of these more advanced layers is code locks. These allow us to lock our JavaScript and make it much harder for it to execute in untrusted or insecure environments. So here we can see a few examples of possible JavaScript code locks. We can allow only some operating systems, browsers, domains, dates, or certain types of devices like mobile phones that haven't been rooted or jailbroken. Each of these locks can help accomplish different requirements. For example, if you have an app that deals with very sensitive data or performs critical tasks, you can prevent it from running on unrooted or jailbroken devices because they are more vulnerable to attacks. And if you want to enforce licensing agreements, you can enforce a product demo. You can deliver a product demo to a client and have the code automatically expire after a certain date. These locks can be especially useful against piracy and license violations. But there's another protection layer that is very useful in every single occasion: self-defending. Well, the name of this layer really gives it away. What it does is add runtime protection to your application with anti-debugging and anti-tampering capabilities. So a motivated attacker may try to understand the code logic of our obfuscated code by debugging it and experimenting with it in runtime to gradually understand portions of the code. When the code is protected with self-defending, it will be able to detect when a browser debugger is open and will break the application immediately to prevent dynamic analysis. It also prevents static analysis and reverse engineering of the protected code by scattering integrity checks throughout the code, so that whenever a piece of code is changed, the application also breaks. And instead of simply breaking our app, we can use different countermeasures coupled with self-defending, like redirecting to another page, or to make them lose all progress and frustrate them. These advanced countermeasures can be used to give you better visibility over attacks on your code, for instance by sending real-time notifications every time that one of these attacks is blocked. Now, you might be wondering how you're supposed to debug the protected code if the code is obfuscated and has all these integrity checks. Well, this is why it's useful to look for a product that provides some additional tools. In the case of Jscrambler, you can use source maps to easily map the protected code back to its original state. And then you can load these source maps into the browser's DevTools, for example, using an HTTP header or by appending a comment to the JavaScript file, like you can see here. Just make sure that you never leak this stuff into production. Another important thing that I haven't really talked about is how you actually integrate a JavaScript protection tool into your development process. In the case of JavaScript, you can call an API to protect the code in the last step of your build process. And to make things easier, we've released the detailed integration tutorials for the main JavaScript frameworks. Okay, now I think we're right on time to see a demo of this in action, so let me get that started. Okay, in this demo, I'll impersonate an attacker trying to cheat in an HTML5 game by tampering with the source code. However, this source code is protected with Jscrambler. Now, I'm going to impersonate an attacker, and my goal could be, for example, to steal the code and monetize it elsewhere, or to cheat to increase my score, or even to avoid having to pay to unlock some features in this game. And if I'm trying to mess with the application, I will try to understand the code and its logic dynamically at runtime. A good tool to do this is, for example, Chrome DevTools, which is useful for debugging the application. So, I will open the DevTools and move over to our Sources tab. As you can see, the application stops once I try to debug it. And even if I try to resume the execution without breakpoints, you can see that the call stack is piling up and I'm always stuck on the debugger loop. This is happening because Jscrambler gave the code anti-debugging capabilities. Now, let me do a step-by-step inspection of this button, which will be charging my account if I wanted to buy a rocket. I'm going to select Event Listeners, and then click. Now I'm able to see some information. Let's just pretty print the code to look at it in more detail. So I can see some code, but it is highly obfuscated. I can't really make any sense of it. So I'm going to select some random breakpoints to do a step-by-step inspection. However, if I do that, the call stack starts to grow, and I'm again stuck in an infinite loop. A good thing is that the app's save state is easily resumed by closing the debugger, so it doesn't really interfere with the user's experience in case a user opened the debugger by accident. Getting back to the attack, the next step will be to statically analyze the code and try to reverse engineer it. In this case, I already have the code on my machine, so my job is simplified. First of all, I'm going to present an unprotected version of this game. You can really understand the flow of the application and all the strings and functions in the code. After being protected by Jscrambler, the same app looks like this. So it's not even recognizable JavaScript thanks to the obfuscation transformations I presented above. As an attacker, I will still try to discover a function here such as eval. I can see that there is an eval function here, and I will make an assumption that whatever variable is being fed to the eval, it will contain the original code as its value. So I'll just console log the content of the variable, save the code, and run the app again. As you can see, the app simply breaks. This happened because of Jscrambler's anti-tampering capabilities. So Jscrambler scattered integrity checks throughout the code to detect if its original functionality has been tampered with. So let's open the debugger again and see what was dumped to the console. The only thing I get from the eval function is just trash and broken references, so it seems I have reached a dead end. Okay, let's just change tracks now for a bit because I want to show you how you would actually protect your source code. So this is the Jscrambler application dashboard. This is where you manage your apps and access the live thread feed for each app, which shows you the threads to your protected code. So I'm going to open the live feed for our Space Shooters app, and now I can see a real-time list of malicious events that happened on the client side. We have alerts for the debugger that was opened, and also the self-defending capabilities were triggered. These events correspond to our previous attacks while I was trying to debug the code of the app. Let's go back again to the Jscrambler dashboard to protect our source code. Okay. On the left side, you can preview the source code by clicking on a file. In the middle of the screen, you can see the original source code and the protected code, which allows you to compare the differences after the protection. Then, this right bar is where you actually configure your protection. You can see that Jscrambler provides some templates that combine specific transformations. Another option is to go to the fine-tuning tab to pick transformations one by one. So you can see a list of all the transformations organized by different layers. You can always hover any given transformation to get a brief description of what it does and to help you decide if it matches your use case. And of course, you can always also check our docs for more details. So now, I want to protect this app with the self-defending template and all the transformations that it includes. I just have to click on Protect App, and in a few seconds I have a new protected version of the protected code. Another relevant aspect about Jscrambler is that the protection is polymorphic. This means that even if you select the same set of transformations, each new protected version will always be different. Let's see this in action. Okay, we can see that this code is different from the one we had before. And to use the Jscrambler API, you just have to download the JSON file here with all of Jscrambler's configuration. So I'll just open it up. And you can see that it contains all the transformations I selected before in the self-defending template. With this, you can easily integrate Jscrambler into your build process by using one of our API clients, such as Grunt, Gulp, and Webpack. There is a cloud version available, and then there are also on-premises deployments where we ship a virtual appliance that you run in your own infrastructure, which means that you never have to send any of your code. Jscrambler also has integrations with all the main frameworks so that you protect your code easily at build time. And I think that's it from me in terms of the demo. Let me just finish with some takeaways. So today we saw that JavaScript is widely used by major enterprises to build apps like mobile banking and streaming. But because this JavaScript is exposed, it can be a target of serious attacks, so things like automated abuse, piracy, code theft, and data exfiltrations are concerns. To counter this, it's recommended that you use JavaScript Obfuscation, transforming the source code into something that's unreadable but works like the original code. Obfuscation should always be paired with runtime protection to make it extremely hard for attackers to reverse engineer or tamper with the code. And this is where most free tools fail, because they are not resilient and can be defeated using reverse engineering tools. And like we saw, Jscrambler provides all of these and other layers to make the code as protected as possible, and even giving live notifications if your app is attacked. And well, that's all that I have for you today.
Thank you, Luis, for your detailed explanation. I want to remind everyone that you'll receive an email with our datasheet on JavaScript security threats, which gives an overview of what we discussed today in just 4 pages. As I mentioned earlier, if you have any specific questions, feel free to reach out to us using the email you see here. And of course, don't forget that you can quickly start a free Jscrambler trial and see it in action by yourself. Simply check the links you see on the screen here. And that's it from me. Thanks, Luis, for your input, and my thanks also to everyone out there for joining us today. See you next time, and don't forget to protect your JavaScript apps.